Okay, so just picking up where we left off on the last video, I did want to give a few hints here on map B that might help out. First thing is, yep, here I just did this one for you. But I do want to point out that it is going to make our lives easier if we pretend that this Jacksonville pressure does not exist. That 160, it makes it almost impossible for us to match it up here. It is technically possible, but it's way beyond what the regions would have you do. So we're just going to pretend that the Jacksonville pressure does not exist. So again, here you get these pressures. I will remind you that I told you to go from the 1000 to the 1024 millibar line. On that note, for a couple of questions here, it says, what is the highest air pressure on the map? This means what is the highest actual pressure that's listed on the map, which is different than question 5 that says, what is the highest value for an isobar? So this is the highest isobar you drew, and this one is the highest actual pressure. Again, answering all these questions, remember we just talked about how to calculate gradient in the last video. I did have the question whether we should use the abbreviated or the unabbreviated. You're going to want the actual pressure, so the 1000 something pressure, not the 3-digit number. All right, moving on to surface wind patterns. This one seems weird, but if you actually follow the directions, it's quite easy. It says on each station model, extend the shaft of the wind arrow and draw the head of the arrow to show the direction the wind is blowing. All that means is, here's a weather station model. What we've learned from the key is that these show the wind the direction is coming from. But to make our lives easier, we want to see where the wind is going. For procedure C step 1, all you have to do is extend that wind arrow to show where the wind is blowing. And yes, you have to do this for all of them. Yes, it might take you a whole 60 seconds, but I'm sure you can handle it. So again, for all of these weather station models, you're just going to show me where the wind is blowing. And to do that, all you have to do is this is the butt of the arrow. You're going to extend the arrow in the opposite direction to show me where the wind is coming from. That's only procedure 1 though. Procedure 2 says to label the high and low pressures recorded in procedure B. Actually that should take us back here. I bet you did not finish procedure 3. So it did want you to label the highs and the low pressure areas using an H and an L. I am not going to do that for you. It is pretty easy to see once you actually look at the numbers. So back here on C, you want to just copy those same H and L over onto this map. And then it does want you to draw 4 large arrows to show the general wind pattern around those 2 highs, or around that high and that low. So you're just going to make yourself a big arrow. This is not where it's going to go, but I'm going to show you what I mean by a big arrow. So you're going to make 4 of these to show how the wind is moving around the high pressure and around the low pressure. So that is going to be done here on map C. Okay, so again, now that you have those all done, you can see, again, we have the high pressure, the low pressure, and the big arrows coming out of the high and into the low. Now you're going to use map C to answer these 5 questions. These are not really that bad, but you know what? I'm going to actually get rid of question 1 here for you. You can totally ignore that. We don't need to, that's not part of it. So you just, again, need to talk about the way the winds are blowing around the high and the low. Map D, again, is not something we've specifically spent time on during class, but we have talked about the basics. So on map D, we need to label the location of the continental polar and the maritime tropical air masses using the appropriate symbols. We also ask you to draw a line around the map where the precipitation is occurring, and then lightly shade where the precipitation is occurring. I'm going to actually start with step 2. Draw a line around the area where the precipitation is occurring. Now, normally on a weather station model, they are shown with the present weather symbol. So you would see drizzle, rain, smog, hail, all shown using these types of symbols. These are actually out of newspaper, and in a newspaper, they don't publish the key. So, and I know it's hard to see, but if you look at Galveston, for example, you'll have to look at yours because it's not showing up on mine. That looks like a dot there, but if you actually look pretty closely, that is an R. So it stands for rain. So what we need to do is connect all these places where rain is occurring. And it's really quite simple. And you're going to come back in and connect them. And then it did ask you to shade that area in. So that is the only area on the whole United States where rain is occurring. Now we need to add in those CPs and the MT. So if you remember, the CP stands for continental polar. That is an area that is cold and dry. So if you look around this map, you should be able to see that this whole general area of the map is dry. Now, I don't know if you remember, but I knew it was dry very easily by looking at the cloud cover. There's no cloud cover. And again, you guys have not lived under a rock for your whole lives. You know, when the sky is clear, odds of precipitation are low. So this whole general region right here is a continental polar air mass. Now we're going to talk about the maritime tropical. That is a wet and warm air mass. Again, here we can see a pretty wet area right here, and the temperatures are all warm. This is going to be our maritime tropical. That's map D. Again, you're going to answer the questions about map D. There's not too many. Now, map E is where we tie it all together. Again, we have to read, it says refer to maps B, C, and A and label the high and the low pressure center. So we can do that right off of map B. So you're going to label the high pressure, which was right here in Salt Lake City. And you're going to label the low pressure, which was right here in Cincinnati. Then the general winds. Those were those 4 arrows we saw coming out of the high. So you're going to add those 4 sets of arrows. And then the 4 sets of arrows blowing into the low. Then we need the area of precipitation. So again, we're going to copy that same area we highlighted in the last bunch. We're going to copy here again, and they do ask you to shade that in. When you shade it in, I want to make sure you can still see underneath it. So we're just doing a light shade there. And now we've done all of that. Now we just need to add in the warm and the cold fronts. So remember, off of our reference table, cold fronts are formed with a triangle, warm fronts are shown with the half circles. We're going to have a cold front coming in here. So you just want to pretty much make a fence. So here it's 60, 58, 40. Here it's 76, 70, and 63. We are going to have a cold front going right down the middle of that rainy area. That cold front. So New Orleans has not gotten cold yet, but Galveston, 60 degrees in Texas, that's unheard of. So you're going to add that cold front right in between those lines. And then a warm front, same deal. We've got 68 here in Hatteras, 63 there, but only a 45 in Richmond. We're going to have a warm front right in front of that rain, or right, I guess I should say behind that rain, my mistake. And ta-da, you are done. You're going to use map E to answer these questions here. And then this last page is a general summary of all of the labs. You're not going to just use one map, but you might need all the maps for this last one. As always, make sure you ask me any questions you might have. This video should have helped quite a bit, but it might not have gotten everything you need. So give me, just raise your hand and ask in class, come up and ask, or if you are out, please send me a message and I'll give you a hand. Bye.